Namaskaram everyone, welcome back to the 44th episode of our Master Unreal series, and in this episode we are going to work on the hand placement for the push objects. So in this case, as we saw in the previous video, our hands were not up to mark because the hands in the animations were a little higher and our cabinet was of a small height. So in this case, I'll show you how you can update the hand position effectively, keeping the performance and resource consumption in mind. We will also go through the control rig solution theoretically, why it's not a good choice sometimes to use a control rig when you are having a animation or interactions where your character is moving. So we will do all the analysis of 2-3 approaches and then we will go for the best one. Apart from this, in this video, I'll also show you that this very implementation can also work for other characters that you might have. You don't have to rely on the SWAT soldier. In the end, I'll show you another character that can use the same interaction system without making any changes. So if you haven't checked out the previous episode, I highly recommend you do that because this system we have been building from past few episodes and we have been constantly improving it. The base structure of this interaction system is already built in the first 3 episodes, and now we are just deriving the use cases to make it better and how you can include all the interaction cases that you see in the games. So please do check it out before watching this video, and if you have already seen it and you are following the series, then without wasting any time, let's get started. Alright, so we are in our editor now. Before I start the hand placement, I want to fix 2 things. First is that I got a report that if you stay too close to the box in the back and if you hold E, the character just pass through and go in the forward direction. So this is happening because when you are calculating the difference, so we will go to generic functions from the content, open it up, and here when we are calculating the difference and normalizing it, I would like to subtract a little amount so that the formula consider the position little away. If you are standing too close, it will just push you a little behind, not in the game, just in the calculation, and then it will measure the dot product. So we will just go back to generic functions and we will first subtract, and the thing that we need to subtract is get actor forward vector, and we will multiply. So this will be 1 in one of the axes and we are going to multiply it by 20 so that 20 meters distance is made. Again, this is something I explained you in the last video. So this is just for calculation. And now we will do all the stuff. Okay. All right. So we are set. We get the actor location. We multiply the forward vector with 20 and then we will subtract it. And then we will do the difference, normalize, and that's it. Now if you compile and play, you go in the back, stand as close as you can, wholly, you can see it is now pushing from other side. Another thing that we were planning to do in this episode is you should be able to push it from all the directions, that is the front or back in our case, and no matter what rotation we keep for this cabinet. So right now if you go in this direction and push, it moves in your direction. So we have to keep account when we are calculating that value in the formula. So we go back to cabinet. In the push cabinet, we consider 25 meters every 0.1 seconds. So what we will do, we will add one more pin and this time we will multiply it with the player's facing direction, because this entire calculation was for the cabinet's rotation and its movement. But when you keep a certain rotation, there are always 2 ways possible. Either it can be pushed from front or back. So if it's pushing from back, then we have to multiply it by that negative sign. So for this, we need to know the facing direction, which we calculated in the position character. This was a local variable. Now we are going to promote it to global. So let's delete it and promote to variable and connect it. Then get the facing direction and plug it here. We do not have left or right, so it doesn't matter if you keep it or not because they are not going to be selected anyway, but still let's keep it unless something goes wrong in the engine, which will not happen though, but still the percentage is like 0.0001%. So the front and the back is the main thing here. Great. So now we can use this facing direction which has been updated here in the push cabinet. So everything we did for the back side was considering that it was +1. If it is pushing from front, then we have to apply -1. So I'll do a select here, connect it with this. Forward -1, backward 1, and left and right doesn't exist, but still let's keep -1 and 1. Compile. Now if you play, hold E, it's pushing fine from the back. If you hold E, it's pushing fine from the front. Let's rotate it in other direction. Let's say like this. Now if you play, hold E, it's pushing fine from the front. If you push from the back, it works fine. Okay, so this solves your direction thing. Now about the hand eye case. Once we are done with this, I'll see if we can implement left or right as well. It will not be a rocket science, something really simple. So for now, let's focus on the hand eye system. Now, many of you might be wondering why not use the control rig, right? Because control rig, you will be able to change the bone rotation, location, and scale as per your requirements, which is something good. But it doesn't work if your animation is dynamic. That means your character is moving. What happens in the control rig? Now just observe what are the drawback of this approach when you have a dynamic interaction where your character is moving. It's not staying at one place. So see, your hands are pushing and this is the point where they are aligning. If I move this down, it will move its hands down, which is exactly what we want. So what I can do, I can just simply communicate this information that the hand should be here and boom, done. So the character will go this way because the spines will rotate. But the problem is when your character is continuously moving, then in that case, this point will not stay. If this point does not stay, then you will go forward and this will remain here. Now just observe what I was trying to show you. I disabled the root motion of this animation. Now observe, it just rotates. So I have to constantly update the location of this particular target where I want my hands to be. So this is not reliable option. Okay. So this is the very reason why I'm not using the control rig, because even if you make all kind of aim mathematics or you apply some formulas or you communicate the information or you figure out the location, you have to constantly update it in the animation blueprint, which is not something we are going to do. This is expensive. So what is the other choice? Second choice is, and also this is not something that you have to do in the control rig. This is also something you can calculate using the inverse transform, which is exactly what is happening in the rig also. You can do that logic here and just send the value over there. But again, you have to send the value, which is not at all an option. So we will use our 2-bone IK to provide the effector value. Now to understand this, what I want you to do is go in your cabinet. In the event graph, you have this key released. So just remove it. What I did here is that if you release the key, it will not listen. It will still keep pushing. That's what we want for testing. Compile and now play. Go and hold the E and release it. Okay, now it is pushing. Now what I want you to do, keep this thing running, make sure there is nothing in the front. I want you to go in your ABP base, in the characters, mannequins, animations, and select this instance. This is the one, the spawned. And in the edit selected instance, I want you to locate your effector location, that variable we created. Okay, now observe. I will bring this blueprint out, go back to my dummy map. We'll keep it here. Now just observe, if I increase the left hand's position, X value, it goes up. If I reduce it, it goes down, and the elbow is adjusting itself too. So this is the place. Let's call it -20. And the right hand, if you increase it in the positive, it goes down as well. This is 20. Now observe here. This is the effector position. But again, we cannot hard code like this. There could be many interactables in your game. You cannot do this for everything. Even if you do it for everything, let's say you change your character. If you do not want to take the SWAT soldier, there might be some other character you might have it, or there's a character switch feature in your game, then you have to update them as well. So you cannot create those many combinations. It's not practically possible. And the another problem is this is something you have to figure out. Now, again, to figure out, you need to perform some mathematics. So, now what I want to say is that mathematics is possible, but the problem is you cannot apply the effector right away. Why I'm saying this is because your hands go gradually. Look at it. Look at your hands. They're going gradually. They are not like going immediately to that position of cabinet to push. They come from bottom. Let's have a look at the animation. You were standing like this. Look at your hands. They are moving and now they are on the cabinet. So up to 23 frames, your hand is moving. So we cannot calculate the effector location correctly, because let's say at this point you said that this is my hand position and the cabinet is placed somewhere here, and now please adjust my hand so that it gets into the place. The formula will calculate that delta and will give it to you, but right at 20th frame your hands are little above, so that effector value will not be applied because that was calculated based on this frame where your hands were in this position at this location, but in the 20th frame you are here. So that means you have to constantly calculate the effector's location till you reach to the static place. And now you see the hands are in a constant location. That means I no longer need to calculate. So there is the same problem. Like in control rig, you were supposed to send the updated location. You still have to calculate the effector location and update it continuously. But that is not a solution we are looking for because there is no difference. And now I want you to pay attention. What is our primary goal? Our x and y value is fine. It is just about the z, the height of the hands. We just have to reduce the height of the hand. So what I will do, I'll say right when you reach to the cabinet in the animation, I want to get that z value and I will just lower it. The x and y, let it be. I don't care. I just want to move my hands down. So I only need to worry about the z axis of the hands location. So I'm saying do whatever you want. Like you take your hands up, then you take them forward. Now, right when you are ready to push, a little few frames before, you will still be somewhere near to this height. I'll get that value and then I'll compare. I will take a delta and then I will apply it, and immediately my hands will move on to that place, because now there is no forward movement, there is no horizontal movement. It's just about pulling the hands down. So we just need to figure out when to pull the hands down. Rest, let the animation work out, because it will take his hand up, it will go forward. Then right when it is going to apply certain tension and a force, we will consider that point where we have to pull our hands down. And after that, look at the hands. They are not changing their position. So that means we don't need to update the effector, because we just updated the effector right at one frame and that is constantly being carried because it is not changing. So this is again the art of reverse engineering that you need to understand. Okay, so this is one solution which is cost effective, because you are going to make the animation blueprint call only once to update the effector's location, and you will just make it at the right point. Okay, so let's apply this. There's another thing that I want to communicate. Like I said, your hands are moving till this point, but they can also be moving after this point as well. Let's say for 2 to 3 frames. The reason is, in the cabinet, you are calling this on interact, which is calling the position character, which is calling the position actor to scene transform. Here you are calling this move to. So our agenda was, we will position you to the idle place, which is front or back. So if you are not at these positions, We will position you, then we will start the animation. Now that movement is asynchronous. What I mean by that is, so there's a possibility that if you're a little away, then it might take some time in the game, and meanwhile your animation starts. So let's have a look in the third person. Look at this clock. This clock represents that this particular function that you're calling will take some time, and what are you doing in the cabinet is right after the movement command is executed and you have immediately started the animation, which means till the point you reach to that frame where you want to update the IKs, the character might still be positioning. The animation is also working and the character is also moving. So you will not obtain the correct IK delta, because delta means change, which means what is the current situation and what is it that you want, the difference. Now we will be executing this once, so we have to be really precise. Okay, for example, this montage will take time to play, that's why there is a clock. So we are going to do the montage play right when the movement is completed, so that there is no other movement other than this montage. So I will compile first, and in the BP third person character, I would like to wait and then notify the cabinet that this is done. Now you can do whatever you want. So in the BLI interactable, we will create a function and call it on player ready, and create an input. We will call it player actor object reference, compile it. Okay. And now in the cabinet, we will double click on the on player ready, and this event will be called, and this is where we will start playing the montage. So let me make some space. Okay, so let's break this, select all the way here, break this one, and we connect it with this player with this and connect it here. Now who has to notify that player is ready? It's the player itself, because we are calling the move to, which is a part of interface that is implemented by this player. So we will call this from here, but we need to know who was the source. So in the BLI kinematics, let's BLI kinematics. In the move to, we will add a new input pin. We'll say callback actor. Okay, so the callback actor, and it's the actor object reference. Compile. Great. So this third person will have the callback actor, and we will check first if it's valid or not, because in the interaction, if the interactable is destroyed, then there is no point of calling. So now we will go for on player ready. Okay, and who's the player? That is the self. So duplicate this. Here goes. Now the move to is being called by the cabinet via generic functions, which is here. Now we need to provide this callback actor. So I'll just drag and connect this pin, and I will rename it to the source actor. Okay, and now you can get the source actor connected with this. Okay, and now this actor to scene transform is called by cabinet from the position character, and the source actor would be our cabinet, that is the self. So let's duplicate it, pass it here. So now this will call, then the cabinet will be passed here, then the move to will call this cabinet again when the movement is completed. Now if you play, hold E, you will see first it position and then it started pushing. Okay. All right, so we have everything ready. Now we have to identify that frame. So we'll go back to cabinet, and in the event graph, we have this animation playing out. And now let's create a function that will update the IK. So update IK position. So now what I want is, I want to update my effector, which is the IK bone of left hand and right hand. So first I need to know the player's skeletal mesh, which is here. So we will get the bone transform from the world, that is the IK hand underscore L. This bone has to be present in your skeleton. Let's go to third person. viewport and skeletal mesh asset, search for, this is the bone, IK hand left and right. Okay, so these are the two bones that we will use. So we will split it, location, then we will subtract, and the left hand was the negative, so we will actually subtract it from the hand position. So this is the backward hand position. We will get its world location. Okay, this is also coming from world, RTS world. Okay, we will subtract it. This gives us the delta. We will duplicate this, and instead of backward hand left, we will do backward hand right. And this time the SK mesh will be at top and this one will be here. And the L will be changed to right hand. Okay, great. So this gives us the change, but we only want it in the Z. So we will return only the Z. So I'll go for make vector and we just want the Z. So split, pass this Z change into X because the inverse kinematic moves in the X like I showed you in the explanation. So I'll do the same thing here, split, duplicate, and it goes here. So this is for left, this is for right. Now we are going to call our animation instance. Okay, so I made it little beautiful. Great. So now we will call our skeletal mesh, which is right here. Let's duplicate it, get the animation instance, and we will update our IK effectors. Okay, and the IK values left goes here, right goes here. Great. So this will update the IKs. Now I'll go in the event graph and now we need to figure out that frame. So let's have a look. So if we play, okay, so right here at the 18th frame, it is now applying the tension, right? See, the wrist is bending, the level is not, only the wrist is bending. So that means the IK bone is now not moving. It is just twisting the wrist and preparing the elbow. So that means this is a perfect place to get the Z. So right at the 17th or let's say 18th frame, we will get the notification that update the IKs. So I'll right click, add a notification, montage notify, select it, right click, change this to 18th frame, and this is exactly at this point now. Now we will rename it update IK. So save it, make sure the name is copied correctly, and now we will add another pin, call it update IK. So this is the point where we will update it. And now I'll call the update IK positions. Okay, so I made it little nice. So we will update our IK positions. Now let's hit compile and play. Let's hold D. Okay, so your hands are exactly on the cabinet. Now let's observe one more thing. This is not what we want actually. Hold the Alt to slow down the time. Now hold E. Observe the first thing. Look at the hands. You saw the twist? Now see another one. It came so fast. So two things. One is that there is an abrupt movement when it is just about to push. Look. Second thing is it comes down immediately. We want the movement to be smoother. So the first problem was your IK effectors were active. What I mean by that is if I go to characters, mannequins, animations, ABP base, actually it should be locomotion layer space, skeletal controls, you have these effectors. So now the effectors are initialized at 0. That means, and the alpha is 1 because there is no curve. So this value is 0, this value is 1, 1 minus 0 gives you 1. That means apply the IK effectors at a full strength. And that is the reason why it twisted for a second, because right when the montage starts, your hand is in this position. Now the IK effector 000 doesn't work well for this one. So what I am saying, before playing the montage, you disable the effectors so that you do not see that twist. Let me show you. If I go to ABP base, locomotion layers base, and I do not update the alphas, I will keep it 0. That means no effectors being applied. If I play, hold the, look at my hands, they're going perfectly fine, which means the natural animation montage is playing out. There is no twisting or corrections in the effectors. So we have to disable it. So I'll reconnect them. I'll go to my BLI anim state that we created for the communication with animation blueprint. In the update IK factors, I'll also go for a new variable that is B disable IK. Compile, go to ABP base. In the interfaces, you will find this variable. So now what we will do, we had that variable, remember, in the locomotion layers base. I told you that some of you might want your IKs to be disabled. That was the reason. I hope the locomotion work and the episodes that we did are working out now. So this disable hand IK has to be updated. So what I'm going to do is, instead of using and creating this variable here, we are going to delete it. So disable hand IK, let's delete this variable from here and we will create it in the ABP base. So promote it to a variable. So this will be updated. Now we are going to use this variable. So in the locomotion layer space, let's access the property access node and we will look for disable hand IK, which is the part of main animation blueprint thread. So disable hand IK. Let me rename it. This should be disable hand IK, not IK. So I'll go here and IK. Save all. And now if I go in the cabinet, right when the animation is about to start, I'll disable it. So let's pull it back. I have the player's skeletal mesh. I'll pull this up. Get anim instance. Update IK effectors. Actually, let's go for a sequence node so that you have things little more arranged nicely. Okay, so now first we disable the hand IK and then we do this. So save all. And now we will enable the IK again when we are updating this IK positions so that new effect that you have applied comes into the picture. And let's plug the skeletal mesh. Okay, hold E, no abrupt movement. Okay. All right. So we have solved our first problem. Now the second one is the smoothing. So I told you in the locomotion layers base, you have this alpha which uses the curve value. So instead of putting directly 1, we will increase it gradually. And the way to do it, if you do not pass anything, it will be 1. If you pass 1, then it will become 0. Now you keep reducing this curve from 1 to 0 and the value will start increasing. Okay. So for example, 1 minus 1, 0, then 1 minus 0.9 is equals to 0.1, then 1 minus 0.5 is equals to 0.5. So this way you will increase this alpha. This is where the hand IK curves comes into the picture, which we also used earlier. So I will add the curve, disable left hand IK and add a curve, disable right hand IK. Now at 18th frame, the IKs are updated. So I do not want to apply the effector right away. Although the notification updated the positions and the IKs are enabled, I do not want them to be applied at full force. So I'll control the force from here. So I'll double click on it, go back and double click on this one. Both are here. So right now the alpha is 1. Let's select this left hand, add a key at the 18th frame, which is at 0.6 second. So 0.6 second, this is the key and the value would be 1. So if I send the 1 value, 1 minus 1 will become 0 because the hand IK is not disabled. So it will go 1, 1 minus 1, 0. So initially no force is being applied. Now I will apply the force gradually. So I'll add one more key and let's say zoom in more somewhere here. Okay, now how did I choose that 0.9? Because right at the 0.9th frame, you are about to apply the tension and the force. And then at 1.08, the block will start moving. So before applying the force or the tension, we have to position our hands. So we have this window from 0.6 to 0.9. So we will adjust our hands. So I'll open this left hand again, and this is the 0.967. That's how I predicted this value. I'm going to select it and I'm going to set it to 0. That means we will start from 1, we will go 0, and the locomotion layer's base will receive 0, and then it will apply full force. 1 minus 0, 1. So with this curve, we are going to pick the values. Now this is a straight line. Let's do this first. I'll do the same thing for right hand. I'll select both of them and then add a key. First key is at 0.6. So select it, 0.6, 1, and then add another key that is at 0.967. So I'll select this key again, 0.967, and the value will be 0. Okay, now these are overlapping. So now if I go back and I scale this down, so control and then use your mouse wheel. In case you do not see like this, just delete the curve and undo so that it looks separated. It's just a editor bug that can happen, so re-add it in case it is not appearing. Now I'll file and save all. Make sure you save. Hold E, look, but again it felt it was little fast, or I must say it was too much noticeable. So what you can do, open this curves again. Instead of going straight line, you can select all 4 points and use this cubic interpolation. This is not a straight line, it uses a little bit of curve. I will select one of the curves first, and now you can control how fast you want to go at 0. This type of curve represents that the value change will happen fast, really with a big difference, and then in later phase it will go very slow. So you can see we have to reach here and we have reached 0 already here. That means this timeline is still unusable. So we want that it should take good time in start and then it should speed up and then it should go to 0. So if we go this way, then this means first apply the change little slow and then go with a full speed and then take some time, a little time here, which is 0.0, and we reach the 0 here. So this is how you control the curves. Okay, so I'll leave this to you guys. I'll save it, play again, hold E, and this is your animation. So I'll go in the cabinet, viewport. This should be little behind forward, so minus 112, and this front should be like something 130, a little further away. And let's select these two backward left hands and increase their height a bit, let's say 100, so that your hands doesn't go inside via edge. If I play again, go in front, hold D, now it is fine. Look at the hands. Okay, so you can adjust like this. Now they are grabbing, somewhat grabbing. I think this much can be adjusted. So now we will go to event graph and then we will connect back this action key release. And if I release, Now you see, this is looking weird. This is because now that effector is no longer valid. So we have to reset the effectors if the montage ends. And this is where we will do the stuff. Make sure is allowed to interact is always the last execution, because this will decide whether some other actor can interact or not. So if someone else comes in, the skeletal mesh will lose the reference of old player. So we have to do all the stuff before. So I'll break this. I will get my player skeletal mesh and I'll get the animation instance and I'll update the IK factors. Okay. And actually, if I look at my player, so play ABP base, this is something we will cover in the next episode, but this left hand doesn't looks good. So if I change the preview instance to the spawn and search for effectors, the left hand should be 6. Now it is looking good. So this is the ideal value. But again, this is something that the equipment system will manage because it is dealing with all the unarmed and other weapon layers. But I'm telling you the ideal value so that we can finish this up. I'll escape and the left hand is at 6. So this is something equipment system will do, not the cabinet. So we will reset the IKs for the unarmed. And then there is another use case that is happening. When you release the key, first this event is called. So we will jump to stop movement. So if you are jumping to stop movement, then you will be in this animation window. Okay. So in this case, we have to cancel the IKs because now if we do not cancel it, the effector will still assume at that height and your hands will tickle. We want to disable the IK because now this is a normal animation playing. We do not want our IKs to work, otherwise the tickling will happen. So we'll go back to cabinet. Once both of these are executed, we will go for a sequence node. And since we have the animation instance in our hand, let's call the update IK effectors and we will disable the IK. Okay. Now we hit compile, play. First we hold E and release it immediately. You see it is good. Try again. Okay. Now if you push and let's go to the idle loop first. I'll push again. Now the idle loop has begun and if I release, it came back. Okay, so before we wrap up, if I push from the back, you see the cabinet moved a little bit. And if we push from the forward direction, it is absolutely fine. So you can fix this by going in the viewport. The back and the front should be at equal distance in X, but in the opposite direction. So front was good, which was 130. We will put negative of this minus 130 here. And if we play and try from the back, now the back will move also from the same place. Another thing, if you do not want your character to move like that when you perform this move too, you can force the shortest rotation path. You can change this over time to 0.01, which means absolutely no time and it will happen immediately. So hold the, okay. Now the rotation took that problem away. By looking at perfectly in center, that move to problem is solved. So now you don't have to see that sliding. Alright, so that's it for this video. I hope you enjoyed it. Do let me know in the comments if you have any suggestions, doubts, or feedback. You can also change this character to some other and try this. For example, I have this VRM rig. I'll try and go to this cabinet, hold E. You can see it works on this character as well. So this is how you develop the solutions. All right. And if you haven't joined the Discord server, please do check it out. And you can find all the assets on the server. You can interact with other members. You can ask your problems, share screenshots. And if you like my work and you want to support my channel, then you can find the Patreon page in the description. Please do not buy any membership without having a word with me on the Discord. So In the next video, we will combine this equipment system with the interaction system so that we can handle the layers. Until then, take care. I'll see you in the next video.